In the next question, we have solid of density 5000 kg per meter cube. The weight of the solid in air is 0.5 kilogram force, and it is completely immersed in water, and density of water is also given, that is 1000 kg per meter cube. They are asking us to calculate the apparent weight of the solid in air. That means they are asking us to calculate the weight in water. So this is a relatively straightforward question. So this is VDLG. So the volume of this body, okay, that is what we don't know. So let us find the volume. Mass upon density, and mass is given to be 0.5 and density is 5000. Okay, so this will be 5 into 10 to the power minus 1. This is 5 into 10 to the power 3. So this will become 10 to the power minus 4 meter cube. That will be the volume. So 10 to the power minus 4 multiplied by 10 to the power 3 into g, because this is 1000. So we get the answer as 10 to the power minus 1 into g, and therefore I get the upthrust as 0.1 kg. Now we want weight inside water, so that will be weight in air minus the upthrust, and that will be 0.5 minus 0.1, that is 0.4 kg. So this will be the weight of that body when it is immersed inside water. Okay, let's move to the next question. In this question, there are two spheres, A and B. A is made up of wood, B is made up of iron. The mass of each sphere we don't know, but the volume that is given is 100 centimeter cube, and this is 100 centimeter cube. The density of the wood is given to be 0.3 gram per centimeter cube, and this is 8.9 gram per centimeter cube. So using this two information, we can calculate the mass. We know that mass is density into water will be 30 gram force, and over here mass is density into volume, that is 8.9 into 100, that is 890 gram force. So the mass of the sphere A is 30 grams and mass of sphere B is 890 grams. So this is 30 grams and 890 grams. So the weight in air will be 30 gram force, and this is 890 gram force. The second part that we want to find out the upthrust. So for sphere A, the upthrust will be equal to VDLG, that will be 100 into 1 into G, that is 100 gram force. Now since 100 gram force is greater than 30 gram force, which is the weight of the sphere A in air, therefore the upthrust that sphere A will receive will be 30 gram force. That means sphere A will start sinking in water. The moment it receives 30 gram force, it will stop sinking and it will start floating. So sphere A is going to float with a part of it inside water, and that much part is giving it 30 gram force of upthrust, which balances the weight, that is 30 gram force downward. Now let's see what sphere B receives. So again, this is VDLG, that will be 100 into 1 into G, that is 100 gram force. Now this 100 gram force, okay, is less than 890 gram force. That means for sphere B, it has 890 gram force as its weight acting downward. Now, when that sphere is completely immersed, it just manages to give 100 gram force. So, therefore, the weight downward is more than the upthrust. So, therefore, sphere B will sink. Okay. So, just listing down the answer, the first answer, weight in air is 30 gram force and 890 gram force. The second is the upthrust is 30 gram force and 100 gram force. And the third part, A will float. You can write A will float partially submerged inside, and B will sink. Okay, that's the complete solution. Let's move to the next question. So what information we have in this question is weight in air of this body is 13.5 kg. Okay, the mass is given to be 13.5 kg. So therefore the weight in air is 13.5 kg. The volume of the body is given, that is 15 into 10 to the power minus 3 meter cube. The first thing that they want is the upthrust that the body experiences. So upthrust we have is VDLG. So that is 15 into 10 to the power minus 3 into 1000 into G. So this cancels, and we have 15 kgf as a upthrust. Okay, so when the body is fully submerged inside the liquid, the upthrust that the body will receive is equal to 15 kg. Okay, so over here they mention it is fully immersed inside. Now the second part of the question is, will the block float or sink? Okay, so here we have weight in air as 13.5 kgf and the upthrust is equal to 15 kgf. So since the upthrust is greater than weight in air, therefore the body will float. Okay, moving to the next part, will what will be the upthrust on the block while the body is floating? While floating, what do we know? We know that the weight in air is equal to the upthrust, and therefore the upthrust will be 13.5 kg. Okay, so you should understand that this body, when it is suspended in air, the weight will be 13.5 kg. But when it is floating on water, the weight will be zero. The apparent weight of a body when it is floating is zero. Okay, because it receives an upthrust which is equal to its weight in air. Okay, let's move to the next question. In this question, weight in air is 175 gram force. Weight in water is 150 gram force. The density of water is given. What is the volume of the brass piece? So upthrust is weight in air minus weight in water. That is 175 minus 150. That will be 25 gram force will be the upthrust. Now, what is the formula for upthrust? It is V dlg, volume of the body, density of liquid, and gravity. So this is 25 gram force. This is V into 1 into G. Why 1? Density of water is 1. So here we get V as 25 centimeter cube. So that's the volume of the body. That's the first part. Now, why does the brass piece weigh less in water? So first of all, the brass piece weigh less in water because it gets an upthrust. So over here, this brass piece, when it is suspended in air, it is 175 gram force is the weight with which it is pulled down. Now, when it gets submerged inside water, it gets an upthrust. So therefore, it is 175 gram force down. It gets an upthrust, what we calculated as 25 gram force, and therefore the downward force is 150 gram force. That means in water it receives an upthrust, therefore its weight will be less. Okay, let's move to the next question. In this question, there is a metal cube of edge 5 centimeter. So therefore the volume will be side cube, that will be 5 cube, 125 centimeter cube. Okay, the density of this is 9 gram per centimeter cube, and therefore mass is volume into density, that is 125 into 9. The mass will be 1125 gram. Okay, so that means when it is suspended in air, its weight in air is 1125 gram force. That will be the weight in air, and the tension in the thread will also be 1125 gram force. Okay, now this particular cube is then immersed in a liquid. Okay, we are immersing this inside the liquid now. So over here, the weight that the liquid has downward is 1125 gram force. This experiences an upthrust. So the upthrust that this cube will experience, that will be V dlg, that will be 125. The density is 1.2 into G. So it is going to receive an upthrust of 150 gram force. So since the upthrust is 150 gram force, weight inside liquid, that will be weight in air minus the upthrust, that is 1125 minus 150, and that will be 975. Now this is the weight of the liquid when it is immersed inside the liquid, and therefore that will be the weight that will be acting on that cube, and therefore the tension will be 975 grams. Okay, so the tension is equal to 975 gram force when that cube is completely immersed inside the liquid. In this question, the dimensions of the block is given. So the volume will be 50 into 50 into 50, and that is centimeter cube. We know that 5 into 5 into 5 is 125. These three zeros I'm writing like this. Okay, now again at the start we had seen how to convert centimeter cube to meter cube. So this will be 125 10 to the power 3, 10 to the power minus 6, and that will be meter cube. So it will be 125 and 10 to the power minus 3 meter cube. This is the volume. Okay, now we have asked to calculate the buoyant force. So buoyant force we know is VDLG. So that is 125 into 10 to the power minus 3 into 10 to the power 3. Now in this question, they have given us the value of G as well, and we have used everything in SI. So we can write G as 9.8. So here this get cancelled. So the answer is 125 into 9.8, and therefore the buoyant force will be 1225 Newton. Okay, this is the answer to the ninth question. Let's move to the 10th question. A body of mass 3.5 kg. So mass is 3.5 kilogram, and therefore the weight in air is 3.5 kilogram force. It displaces a volume of 1000 centimeter cube. Okay, that will be the volume of this whole body. Okay, because that much volume of water it is going to displace. You have to calculate the volume of the body. So the first answer, volume, is 1000 centimeter cube. We can express it as 10 to the power minus 6 meter cube. That will be 10 to the power minus 3 meter cube will be the volume. You can either express in centimeter cube or meter cube, no problem. The second part is upthrust. So upthrust is equal to VDLG. So volume, if you are writing as 10 to the power minus 3, that is meter cube, then density of water has to be written in SI, that is 10 to the power 3. So this will give you 1 into G, and therefore I get the upthrust as 1 kilogram force. And coming to the third part, what is the apparent weight? So the apparent weight, that is weight in water, will be the weight in air minus the upthrust. And weight in air, we know it is 3.5, and this is minus 1, so that will be 2.5 kgf. So this is weight in water, or which is also known as the apparent weight. Okay, so in the next video we'll see some more numericals. Thank you.